Hello, everyone. I'm Ho Hao, currently pursuing my PhD from National University of Singapore. So I'm here to present a piece of our research work that is accurate matching between BIM render and the real-world image. Also, I would like to thank the organizer to provide me with an opportunity to present this. So before start, let me briefly introduce who we are. So my main research interests are in the potential application of ground robot for monitoring the interior progress monitoring. I focus on problems like robotic vision, model-based navigation, robot localization in BIM. Also, our group are working on a research project aiming to generate the building handover inspection report using the Boston Dynamics board. And basically, we are interested in how to adapt the ground robot into built environment. So let's start this presentation from the background. So we know in interior space, commonly used positioning tools like GPS is unreliable due to the signal strength. So considering this, BIM as a prior model have the surrounding geometry information has been studied to assess the localization. For example, the robot can be localized by matching the camera capture image with the corresponding BIM image. So however, we have to notice that perception gap exists from BIM and reality. The appearance of BIM image are significantly different from the real-world image due to the depiction style, the textures, lighting conditions. So it's very challenging to match this image like the safe base. So considering this, some related works try to apply the style transfer technique to BIM render image to generate a more realistic image. They are further matched with real-world image to estimate the pose. And also in BIM PoseNet, BIM render image and the corresponding pose were fed into the deep learning model to estimate the pose of real-world image. So however, the dataset preparation of training deep learning model is time-consuming and costly. So the generation ability of this model need to be further studied as well. So therefore, we want to ask, is there any feature detection technique that can address this perception issue? As we know, in recent years, many learning-based models have been developed to detect the key features on image. So this trained model has shown strong robustness to images under various illuminance and style conditions. One well-known model is D2Net. Therefore, in this study, we are curious whether the key features detected by D2Net can be matched and help bridge the perception gap. So here is a high-level concept of our invasion study to rectify the pose. So we have a rough robot pose by STEM. Based on this pose, we retrieve the perspective in BIM, and the robot camera capture image is matched with a BIM image to rectify the pose. So in this study, we'll only focus on how to match the image, and we'll use D2Net detected features to achieve the matching. So here is the result of D2Net based matching on BIM and render, and BIM render and real-world image. So the first metric is a projection error. It's a Euclidean pixel distance between the project key points and the matched points. So a homograph metric is manually computed to conduct the transformation. And also the other metric is the number of good inliers after the neighboring search and ransack. So we can see compared from the table, we can compared to safe, D2Net can reduce the mean projection error from around 187 to around 16 pixels. It also has more inliers, which is 55 against the 11. Overall, it shows D2Net has the ability to match the image and fill the perception gap between BIM and reality. And in short, this study has one contribution is it shows an accurate and robust technique to match the BIM render and real-world image is superior to other technique like safe-based matching, in terms of projection error and number of inliers. And some of our potential future work are to estimate or rectify the robot pose in BIM by using these detected key features to have a better aligned perspective between BIM and reality. Also, we can conduct experiment to fit more built environment image to fine-tune the D2Net model. Definitely, it could work, and also it can improve the robustness of this model as well. So that's our presentation. Thank you.